go into a little more detail on graphing quadratic functions. From the previous section, we've discovered that if we're graphing by hand, it's much easier to graph a quadratic function that's in the form of ax subtract h squared plus k than it is to graph when we're in our standard form f of x, ax squared plus bx plus c. So what we want to look at today is how can we go from this form, ax squared plus bx plus c, to a times the quantity x subtract h squared plus k, and to do that we're going to complete the square. So let's work through an example of this. We have a function, it's quadratic, f of x equals x squared subtract 4x subtract 5. And first thing we're going to do is just go ahead and call the f of x y. That's just a little more compact notation. So then what we're going to do is move the constant, which in our case is this -5, to the y side, and leave only the terms with x's together on the right side of the equation. So since it's a subtract 5, we're going to add 5 to both sides. So now I have y plus 5 equals x squared subtract 4x. Now I'm going to need the magic number to add to both sides. And again, to find that magic number, I take the coefficient of the x, which in this case is -4, divide it by 2, and square it. So -4 divided by 2 is -2, and -2 squared is going to be +4. So I'm going to add to both sides is 4. So I'll have y plus 5 plus 4, which of course will give me 9. Then x squared subtract 4x plus 4. So it's still an equivalent equation because we've done the same thing to both sides. I'll simplify the left-hand side. That gives me y plus 9. And then I'm going to factor this side. You can use the shortcut if you want, or just factor it. And this will give me x subtract 2, x subtract 2. So whenever we complete the square, they should always factor into those twins like that. So now I've got y plus 9 equals x subtract 2 squared. I want to isolate the y again, so I'm going to subtract the 9 back over to the other side. And then I'm going to rename the y as f of x equals x subtract 2. There we go. Subtract 9. Now I'm in the completed square format. My vertex will be +2 and -9. My h and my k. Remember again that it's x subtract h, so the h is a +2, and then it's plus k, so plus -9, so my k is a -9. It's my vertex. And if a is something other than 1, it does get a little messier than this. Just have to do a little more factoring, and we're a little more likely to run into some fractions, but we'll cover those in Math 111 next term. While we're at it, we can also find the intercepts. For the y-intercept, let x equal 0 and then find y. So if we let x equal 0, again f of x is just a fancy name for y, put 0 in for x. And what we're left with is simply the constant. So our y-intercept is 0, -5. And then the x-intercept, so we let y equal 0 and solve for x. And with the x-intercepts, you may have two x-intercepts, there might be only one x-intercept, or there might not be any x-intercepts because the solutions are non-real numbers. Whereas with the y-intercept, there will always be exactly one y-intercept. So to let y equal 0, and I think what will actually be a little easier, now I'm going to use the other form. We completed the square and got f of x equals x subtract 2 squared subtract 9. So let's just go ahead and use that form to solve for, because they're equivalent. And since we've gone through all that work of completing the square, our two x-intercepts are at 5 and -1. So that's 5, 0, and -1, 0. Our vertex, again, we said was at 2, -9. let's see if this all makes sense. So if our vertex is at 2, negative 9, I should have left myself some more room here. Let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9. I've got an x-intercept at 5, 0, and negative 1, 0. And then my y-intercept was at 0, negative 5. Okay, it's a pretty messy graph, but it all kind of fits together there, doesn't it? The vertex is right in between the two x-intercepts, and the y-intercept is there on the way between the vertex and the other x-intercept. Okay. So, another example going through that. We've got y equals x squared plus 6x subtract 1. First thing I'm going to do is move the 1 over with the y. And then find my magic number. So I'll take the 6, divide it by 2, which gives me 3 squared will give me 9. So I'm going to add 9 to both sides. Simplifying the left side, I get y plus 10. Factoring the right side, looks like x plus 3 and x plus 3. So I've got y equals x plus 3 squared, and I can bring the 10 over, which will make it a negative 10. So my vertex will be at negative 3, negative 10. Okay. There is another way to find the vertex of a quadratic function, and I like this one when my a, b's, and c's are at all messy. The x-coordinate of the vertex is going to be simply this formula. H equals negative b over 2a gives me the x-coordinate of the vertex. And then once I've got this value, I can plug it back into my equation for the x value, and then calculate the y value to get the y-coordinate of the vertex. Now you may be thinking that, oh no, one more formula to memorize, but you actually know this already because you know the quadratic formula. The quadratic formula, x equals negative b plus or minus the square root of b squared subtract 4ac all over 2a. If you look at the quadratic formula and just ignore all of this stuff, negative b over 2a. That's our formula for the x-coordinate of the vertex. Okay, so we're usually the most are story problems where the numbers aren't as nice for completing the square. So we've got a ball's thrown in the air. Again, classic example for a quadratic equation. The height in feet after t seconds is given by this function. So for a given value of t, we can calculate the height of the ball. Looking at the function, because the leading coefficient a is negative 16, we know that this is going to be a parabola that's upside down. So the vertex will be a maximum. And what's going to happen at the vertex, that's going to be the highest height that the ball reaches. So using our formula, h equals negative b over 2a, the vertex will occur at where t equals negative 48 over 2 times negative 16. So that's negative 48 over negative 32, which will reduce down. Those are both negatives. The negatives will cancel out. Looks like 4 would go into both of those. Let's see, that gives us 12 over 8. Reduces down again. Another 4 goes in there. 3 over 2, or 1.5. So the ball will reach its maximum after 1.5 seconds. Again, because t is being measured in seconds. Then to find the height the ball reaches, we can evaluate the function at this value of t, 1.5. So negative 16 times 1.5 squared plus 48 times 1.5 plus 64. And I think I'll just run that through my calculator real quick. You probably got there before I did. That gives me h equals 100, and this is going to be in feet. So for this particular arc of a ball thrown in the air, starting at a height of 64 feet, initial velocity of 48 feet per second, -16's gravity, the ball is going to reach its highest height after 1.5 seconds, and will reach that height at 100 feet.